Hello and welcome to today's video. Today I'm going to be looking through this paper from the STEP sixth term entrance paper, Mathematics 2, which is the Cambridge entry paper for undergraduate studies in mathematics. So I'm going to look at question 1 with both parts, 1 and 2. And with any typical STEP question, you should be expected to spend a while or at least you should expect to spend a while on the question itself, as they're not usually the same sort of style as an A-level question. So let's have a look at what we've got to do here. So we've got to sketch this curve, which is an odd-looking curve. It's the square root of, well, it's the square root of 1 minus x plus the square root of 3 plus x. So it's an unfamiliar graph to most students, I suspect, and then after you've sketched it, we can then see we have to solve this equation and find that there's only one real value for x which satisfies this equation. And then in part 2 we are going to be expected probably to use some of the stuff from part 1, or at least the ideas thereof. So without further ado, let's start. So what we've got to do is this, just right here, part 1. And we're going to write down what we're given, which is y is equal to the square root of 1 minus x plus the square root of 3 plus x. So how do we know what to do first? Well, what you should always do is think, what can I do? What am I allowed to do? What am I certainly not allowed to do? And what am I constrained by? So here we have the square root. Now, for this to be a real number, as we all know, we cannot take the square root of a negative number and have a real solution. So what we're going to do is we're going to have to realize that this inside the square root has to be greater or equal to 0, and obviously this part also has to be greater or equal to 0 for this to be defined in the real numbers. So that means that x has to be less than or equal to 1, and x has to be greater or equal to minus 3. And so if we draw a little number line here, or the real line, x-axis, then what we get is we get that x lives between this value 1 and minus 3. So when x is outside of this range, this graph is not defined. That means there will be nothing above or below the graph, above or below the x-axis. Now, what we're going to do, and obviously this is 0 here, what we're going to do now is have to think about where y is going to be. So if you can see at this equation again, all the terms from the square root are positive. And so since you can never have a square root of the inside being negative number, then that means that this is always positive and this is always positive, so therefore y is always positive. We know now that y will live above the x-axis. And well, what's obvious to do now is to think, okay, what about the endpoint? So if we let x be 1, we're going to get 0 here, and then we're going to get 4, and then we square root that, so we get 2. So we know that when x is 1, if x is 1, then we get y is going to be 2. And similarly, we can see if x is going to be minus 3, you're going to get 4 here and 0 here, so therefore you'll get x is going to be minus 3, y is going to be 2 again. So it just helps us to think about where the graph is going to be. And we notice that it's going to be symmetrical about x equals minus 1. So actually what we're going to get is a graph which is going to do something, maybe go up or down, maybe a straight line, but we know it's going to start and end at a point that's y equals 2, because that's what we've got. So it may have more curves in the middle, and we can only determine that really by some calculus. So what we're going to do is we're going to differentiate it to find out what happens to the gradient over the period between x equals minus 3 and 1. So if we differentiate, then what we're going to get is that if you differentiate this, you'll see the minus 1, so we use the chain rule. So we're going to get the minus 1 at the top, we're going to have 2, and then we're going to have the 1 minus x, because that's x, well, this whole thing, the square root will be 1 minus x to the power half. Differentiate it, you bring down the power, and then you bring the power by 1, so that means that you'll have a half minus 1, which is minus a half, which is exactly what we've got here at the bottom. So similarly, we'll have this for this part. Now, we can see immediately that if x is 1, this thing goes to, well, the bottom goes to 0, which means 1 and anything divided by 0 is going to be blowing up to infinity, either negative or positive. In this case, it's going to be negative. So what we're going to get is that we're going to get this very steep gradient here at 1. So we can just imagine this sort of thing. And it's going to be infinite here, which corresponds to being a vertical line. And similarly, if x is minus 3, we're going to get this very steep gradient here. And so now we've already got a rough idea. So now the question is, does it blow up anywhere else? Well, this can't go to infinity over this finite range here, this interval minus 3 to 1. So we suppose that it must have some sort of maximum, and we want to find that out. And so what we're going to do is we're going to set this gradient equal to 0, because when you set the gradient equal to 0, what you're doing is you're just having a 0 gradient means that you're parallel to the x-axis. So it's going to turn round. You want to know when it turns round. So therefore we set gradient equal to 0 to find maximum y can achieve. So doing that, we can then see immediately that we're going to get this equation here, minus 1 over 2 times the square root of 1 minus x plus 1 over 2 times the square root of 3 plus x equal to 0. Now, if we do a little bit of algebra and think about it, we're going to have to multiply the denominator up to get common denominator, and then what we're going to do is multiply that common denominator, which will be 2 times the square root of 1 minus x times the square root of 3 plus x. We multiply that up, and then we get 0 here, so we're actually going to end up with, moving this to the other side, we're going to end up with, cancelling the 2 because it's non-zero, we get 3 plus x. Oops, make that x a bit better. Is going to be equal 1 minus x. And then when we square both sides, that's how you would solve this, and you notice 3 plus x equals 1 subtract x, and so what you're going to get is you'll get that 2x is equal to minus 2. So you'll get 2x is equal to minus 2, implying obviously that x is going to be minus 1. So we found that maximum value, and notice there were no other solutions to this equation apart from x equaling minus 1. So that means, therefore, that we have the graph, really. And if we're a little bit perceptive for this equation here, if you do think about it, it will be symmetrical around minus 1. If you put in minus 2 and then you put in 0, you'll get the same values. So that's basically something you can notice as well, which might cut out the need to do calculus, but that doesn't necessarily help. Let me just draw an axis and make it a little bit neater. So here we go. So I'll just draw this axis here, and then I'm going to label it. Make the screen big again. So we'll have y-axis, and then the x-axis, and then we're going to have 1, minus 3. And as we said, it's going to have this maximum, sort of in the centre around here. Maybe that's about minus 1. It doesn't have to be perfect. You see, the whole point is that you need to get a rough idea of the sketch rather than the perfect graph. So what was the value at each end? It was 2, wasn't it? Yes. So we're going to get this, and it's going to go something like all that. And of course it's a sketch, so it doesn't matter if it's not entirely accurate. We can see that there's an axis of symmetry around that part there. Good, so now we're going to use this now to hopefully find our solution. So I'm just going to actually copy this graph because I'm going to solve this equation that we've got here in the question, which is here, square root of 1 minus x plus the square root of 3 plus x, which is exactly our y, and then we're going to equate it to x plus 1. Well, graphically, x plus 1 will be here. So if we draw the graph of y equals x plus 1, well, that goes through x-axis here, obviously at 1, and has gradient 1. So when we do that, we're going to go through this point here. And obviously we can see that x is 1 corresponds to the value of 2. So there is only one solution, because it hits the endpoint once. So therefore, from the graph, sketch, we see that the equation square root of 1 minus x plus the square root of 3 plus x is equal to x plus 1 has a solution 1. You can see that quite clearly. That's 0. That'll be 4, which is square root, you get 2. And then here you get 1 plus 1, which is 2. So we can see that, and we can see that it's the only solution. It's satisfied by. Satisfied just means that the equation is true for this value x equals 1. And only x equals 1. Good. So now we can go on to part 2. So if we go back and see what part 2 is asking us. So we've got to determine graphically the number of values that satisfy this equation now. So this one looks a little bit harder because before we had some other y equals x plus 1 rather than square roots everywhere. And so immediately what we have to think about is maybe considering the left-hand side as a function of y, and then the right-hand side as a function of y, or at least set the graph y equals to the left-hand side and y equals to the right-hand side. So doing that, hopefully, we'll be able to see graphically a very similar idea to what was here to find solutions. If you think about the two graphs intersecting, then you will get one solution. If it intersects in more than one place, then you will get the number of intersections as solutions. Okay, good. Let's have a look at question 2. So what we're going to say is consider the graph y equals, well, we're going to consider the 3 plus x first, plus, so we did this first before, it seems to make logical sense to consider this one. So we've got this here. Now, again, so what you have to realize, obviously, is that this is the square root, so we have to have that, obviously, then for real values, we require or need both 3 plus x to be greater or equal to 0 and 3 subtract x to be greater or equal to 0. Immediately you can see, therefore, that x lives, therefore x is here between 3 and negative 3. So now what we're going to do is we're going to consider, well, we notice one thing is we can consider lines of symmetry if we can find any. Always look for symmetry in maths problems. If you can find any sort of invariance or some sort of way of seeing that there is a symmetry in your graph or your problem, then that will help a lot. So we can see that immediately here, because if you plug in a negative value of x in here, this will turn to the positive, and you'll essentially have this transforming to this and this transforming to this and vice versa. So therefore what that means is that any value of x that you put in that's negative will give you a value of y for which that same value of the x which is positive. And so I'll just draw sort of what I mean. So let's say you put in the value of x here, let's say 2, you get this value out here, let's say y, then it doesn't matter, you're going to get the same value here for y. That is known as being an even function. If you carry on with your studies in mathematics, you'll study even functions, or at least you'll use them because they've helped greatly to solve problems. So, and an example of an even function is actually the cosine function. So that's all values of cos of x are equal to the values of cos negative x. So, and having that in mind, then we know that it's going to have some sort of maybe an inflection point or a stationary point. So we can see immediately, though, that obviously it's going to be 3 here. If x is going to be 3, we're going to get 0, and then 3 plus 3, which is root 6. So it's going to go from root 6, go up or down. We don't know which, so let's just calculate the gradient function again. Just a simple calculus. We can see that dy by dx is going to be, and then we obviously have to think about 2, 3 plus x, and then negative 1.5, and then that's 3 minus x. Setting this equal to 0, we will find that, well, we'll get 3 plus x equals 3 minus x after a little bit of algebra. And as you can see, the these will cancel, and then you'll get that x is equal to minus x. Obviously, there's only one solution to that, and that's going to be x is going to be 0. Okay, so that confirms our suspicion that this graph is very similar to this one, in fact, only that it's going to have symmetry around the y-axis. So what we're going to get is this graph here. Let me just draw it, or sketch it at least anyway. So we're going to get 3 here, negative 3 here, let's say, and then we said it was root 6, didn't we? Something like this. Maybe this is root 6. It's going to go up, and it's going to have, well, at 0, we're going to get 2 root 3, aren't we? So we're going to get 2 root 3 here. It's going to come up and go around and look something like that. So what we're going to do now is we're going to sketch the left-hand side, and then hopefully we'll find that they intersect or don't. So if we can try to do that, that's the main idea, I think, of this question. So, and just remember, there may be more than one way of solving the problem, but as soon as you see a way in, unless you can see a better way, of course, then you have to go with what your instincts are. So, yes, okay, so I should label this maybe y equals square root of 3 plus x plus the square root of 3 subtract x. Right, now we're going to look at the other one, which I remember correctly was, let's have a look, 2 times the square root of 1 minus x. Yes, that's right. So we say now consider, and it always good to use words when you're writing. Now consider the graph. I'm going to express your logical idea of y is equal to 2 times 1 minus square root of x. It was 2, wasn't it? Sorry, I don't want to make a mistake. Yes, okay, good. So when we do that, we're going to immediately notice this again has to be greater than or equal to 0 inside the square root. So we know that that means that x minus 1 is greater or equal to 0, so therefore x has to be less than 1. Therefore x is less than or equal to 1. And when we can see when it's equal to 1, we're going to get that it's going to be 0. So we know that y equals 0 when x is equal to 1. So, and then what we can see actually is that this is, if you look at it, is just the same as a parabola, a horizontal parabola rather than a vertical one. So if you square both sides, you're going to get, notice, if squaring both sides, we can see that it's a parabola when squaring both sides of, let's see, star, we get, so we get y squared obviously, and then we're going to get 4 times 1, and then subtract 4x. But we can rearrange this obviously so that we get y squared over 4. Well, we can actually get the other way around, subtract negative and then add, so we get the 4x is going to equal to 4 minus y squared, and then we divide by 4, we get that x is going to equal, as I said, 1 subtract 1/4 y squared. So if you think of it as a function of the other way around, x is a function of y, y is a function of x here, then what we're going to get is a parabola in y. So that corresponds to this graph here. So what we're going to do is we're just going to draw another axis, and then we're going to try to sketch this. So a parabola. But notice it can't, although from this equation we can see that it could be plus or minus, but the point is here we've actually just got the positive branch. So that corresponds to this side. And then notice it can only be positive, so we get, let's try and draw this a little bit better than that. Okay, so let's see something like this. So this is going to be y is equal to 2 times 1 subtract x. Let's see, x-axis, and if you think about it, y-axis here. If you swap them round and you get exactly a parabola that was going out like this for y equals a parabola. So anyway, so what we're going to do now is we're going to obviously draw these two on the same axis. So what I'm going to do is I'm just going to move this over here, and then put this. So this is 1. This is -3. So what's this point going to be? Well, we can see that when x equals 0, y is 2. So we can see that this is less than this graph here. This is √6, and this is 2√3, sorry. And obviously 2 is obviously larger than √3. √3 is between 1 and 2, but then if you multiply that number by 2, 2√3 will be bigger. So we're going to get the intersection here will come down, and it comes down obviously here, something like this. So what we get is, you can see immediately that there's this one solution here. Now, therefore, there is only one real solution anyway. Good. So what we're going to do, and it's a negative value, what we're going to do now though is find it. So how do we do that? Well, it's the most obvious thing to do seems to be to solve the equation itself by brute force, by squaring, because we've got square roots. That makes sense. So let's have a look and see what we get, and we should get a quadratic, and we've got to be careful when we take it, because obviously quadratics will have two solutions. What we're going to do is, we've got that 2 is multiplied by square root of 1 minus x, and then we're equating that to 3 plus x plus 3 minus x, and squaring that, you're going to get that 4 subtract, well, we're going to get 4x here. And if we square this, we're going to get, if you think of this as a and plus b, we're going to get a squared plus b squared plus 2ab. And so when we square, we'll see that this will go to 3 plus x plus 3 minus x. We'll end up with a 6. And then we're going to end up with 0, because x plus negative x is 0. But then we're going to end up 2 terms of the square root parts. So we'll end up with this. And then what we're going to do is, we're going to move this 6 to the other side and then square again. And when we do that, what we're going to get is -2. So we can see that 2's will cancel. If we cancel everything out, we'll get that this is going to be -2, but then we cancelled, so it's 1, -1, subtract x, and we're going to square that. And then we're going to see that we get 4. No, we're not going to get 4, are we? Because we've just cancelled by the 2. So we're going to get that this is going to be √3 plus x, no, not root. It's just going to be 3 plus x times 3 minus x, which you can immediately see is the difference of 2 squares. And this is just the same as x squared, x plus 1 all squared, x plus 1 all squared, because the negative will cancel, or can factor it out, and then obviously a square of -1 is 1, so that we get x squared. Have I done this right? No, I haven't done this right. It's going to cancel. This will be a 2 here. And this will be a 2 here. Hang on, let me just think what we've done wrong here. Bear with me 1 second. Yes, we should end up with -2 subtract from -4. Of course, yes, that's right, exactly what I said, 2 here. So that's 4x plus, and then the 1, which is equal to 9, subtract x squared. And then what we're going to do is we're going to rearrange to get 2x squared, 4x squared. So that's already 4x squared, isn't it? Oh dear. Right, so we get so easy to make mistakes when you're not concentrating. So that's why we should write our work out nice and neatly so we can easily check back to see. So what we get is 5x squared plus 4x, and then we're going to subtract 8 and then set that equal to 0. Now, the easiest way to solve this is probably by using a quadratic formula. So we're just going to do that, and I've already simplified it a little bit. And what you'll find is that you're going to get x is equal to, so negative 2 subtract 2 times root 11 over 5. And notice it's plus or minus, obviously. However, we're only concerned with the negative value because that corresponds to this one here. So, however, we know that x is less than 0, so that x is equal to negative 2 subtract 2 root 11 over 5 is the required solution. Good. Okay, so an introduction to STEP. So in one sense, not that hard a STEP problem probably. However, you have to be careful, and what you have to do is you have to notice patterns, and you have to think about what you can do and what you're allowed to do. What are the constraints of the question? That will guide you. And also, you know, once you start, you can, you know, think about, well, sketching a curve is going to involve taking the derivative here, and then what we can see is this, the whole question is really about trying to think about the left-hand side and graphing that, and then thinking about graphing the right-hand side, and then putting the graphs over each other, and then seeing how many intersections there are, and then obviously the question falls out nicely. So I hope you enjoyed that video, and check out my next one whenever it appears. Thanks for watching.